Today we're looking at creating our own dot matrix display that has multiple uses. For example, it may be just a door sign for a joke, or it could be a kid's bedroom, Jimmy's room, Mary's room, that kind of thing. It could be something you put up in the window to celebrate somebody's birthday, or somebody's wedding anniversary, or Merry Christmas even. I've got a friend who's got his own cinema room, and above the door he's got a scrolling display that advertises what movie is going to be showing that night. Or if you really want to be frivolous, you can have something in the back of your window in your car or in the house window come election time. But from our point of view, we're actually looking at it for model railway use, particularly for exhibition layouts. Something like this. The modules used for it are quite cheap to buy, as you can see there, and you can wire them in series with each other to get longer strings of characters. That example shows a block of 4 separate modules. And here is one of those modules. The top part is simply a matrix of LEDs that plugs into a small PCB underneath. And the switching of the LEDs is controlled by that chip that we'll look at very shortly. If we look underneath, we'll see that the PCB connections on the right hand side carry on all the way through to the left hand side. That allows you to connect 2, 3, 4, as many as you require, in series with each other to get longer lengths of characters. It also means that you can separate that block into individual PCBs or blocks of 2 or 3, whatever your needs are. If we look more closely at the individual module, you'll see there are only 5 pins that connect all the way through to the next module. The top 2 are simply for power. The module runs at 5 volts. And the other 3 are used to take the data from the microprocessor to say which LEDs you have to light. Those 3 are using a method called the Serial Peripheral Interface, SPI. The only parts we're concerned with are chip select, which means turn on the module. Data in clearly is talking about the data you want to display. And the clock is there simply to synchronize between the chip that's in the module and the microprocessor itself. Here is the specification for the max 7219, the chip that's used on the module. If we zoom in to the bottom right, you will see an example of its usage. The areas that I've shaded are the parts that are already on the module, the chip itself and the collection of LEDs. And on the left we have the microprocessor that's going to control it. It could be a microchip PIC, it could be an Arduino, it could be a Raspberry Pi, or whatever you choose. And we can see the three connections between the microprocessor and the module. The data, the chip select, and the clock. For this build, I'm going to be using an Arduino Nano, so let's have a look at its pin connections. And you'll see there that it has, at the top left, serial connection, and then middle right you'll see there I2C connections, and along the bottom we have the SPI connections. SPI is designed to be a fast interface between microprocessors and various devices, and you'll see there as a consequence that there are two connections bottom left marked MISO and MOSI. MOSI means master out, slave in, which is how we're going to use it, because the master is going to send out data to the module. We don't need MISO, which is master in, slave out. It's used when you have to receive data from devices such as temperature gauges or whatever's connected to the SPI bus as input devices. And bottom right we have the SPI clock. We're able to use multiple chip select pins if we wanted, using the digital outputs, which is very handy if we've got several SPI devices connected to the bus, and we can switch them off and on with only one active at any one time. We only have, of course, one device connected, so here's the final setup. The SPI clock is going to the dot matrix module's clock pin. The MOSI pin of the Nano is going to the data in pin of the module, and digital 3 here is being used as the chip select. And now we're able to wire the Nano directly to the dot matrix module. And here is the built example. I've got an extra push button and switch, but we'll cover that a bit later. Let's get a bit closer, and you'll see there are only 5 wires connecting the board to the dot matrix display. The Nano is mounted on a piece of perf board and then wired underneath with links to make the connections. It doesn't have its own voltage regulator because, as you can see here, I've put it into a box that'll be protected during exhibitions. You'll see there the voltage regulator bolted to the side of the case for heat dissipation purposes. Well, that's the hardware taken care of. But how do we program the Arduino Nano to make it all work? Well, there are many different methods, and we want to stick simply with putting text on the screen, but there are other methods that allow you to create objects and so on. But we're looking purely at getting text on the screen. So here is a basic example. It's only 15 lines of code, but let's just break it down line by line. As always, we have two main procedures, one that sets things up and one that contains your main code of the program. So firstly, we're going to use code written by others to make life easier for us. We're going to include these routines into our code at the top here. First one is the SPI, the code that allows the Nano to talk to the dot matrix. And then we're going to add in code that knows how the dot matrix display works. And finally add in code for special effects such as scrolling. We don't need to know how these bits of code work. That's the whole idea. All we need to know is how to use them. And now we come to the code that's specific to our program. We've got 3 extra lines here. Firstly, we're telling it what version of the dot matrix display we're actually using. Then, because we're using 3 of those blocks of 4 characters, then there'll be 12 devices we want to write to. And then finally, we tell it which pin we're using for the chip select. And now there's one line that ties it all together. Every time we use the word My Display, we're talking about the hardware that we've just configured. And now we can move on to the setup. Firstly, we're going to initialize the display. Then we're going to decide just how bright the LEDs will be on a scale of 0 to 15. Personally, I found if it's up at full brightness, it's just too bright. And then lastly, you clear the screen. In other words, you set all the LEDs off. And at this point, we can then enter the main program itself. And there we go. What an anticlimax. There's only 2 lines of code. One is to set the alignment. Remember, we've got 12 characters on this display, and the text you want to display needn't be 12 characters long. It may only be 5 or 6 or 8 or whatever. And you can decide whether you want the text you display to be in the middle of the 12 characters, or a line to the left, or a line to the right. And the last line just says what you want to display. That's it. Now you recall that my earlier image showed a push button and a switch. That's because I wanted to be able to switch between different text on the screen. In fact, there's nothing to stop me having a rotary switch and having multiple messages. And there's the code that I chose to use to achieve that, with a choice of text depending on which way the switch was set. Note also that instead of taking the alignment option, I've chosen here to scroll the text. It simply entailed adding in an option switch onto one of the digital inputs of the Nano. I also put in a reset button. And the final result looks like this.